Page 1 of Properties of Curves. We're going to talk about tangent lines and normal lines. First of all, in order to easily write the equation for a tangent line or a normal line, one of the handy formulas to know is the formula which allows you to write equation of a line from a point and a slope. And that normally is called point-slope form. I guess you could call it gradient point form or point gradient form if we're going to say gradient instead of slope. The way it works is you have a point defined by x1 and y1. So you put a point coordinates in there, and then you put your slope into m. So let's take a look at the reading. So we have a function, which is a curve, right there. And then there is a certain point that we choose to lean the tangent line up against. It's that point right there. And the x-coordinate of this point is going to be a. Okay, we just say it's a. It's a number, but we don't know exactly what the number is. And the y-coordinate of the point is going to be a plugged into the function f, which makes sense, right? So that's the x and that's the y. Now, if we are looking at the tangent line, which is this line right here, it has a certain gradient or slope. They're calling it m subscript t here, t I guess for tangent. But you know that if you are going to find the gradient of a tangent line at this point of contact, you could find it by taking the derivative of the function f and inserting the number a, which is the x value, right? Because the derivative function is the one that tells us what the slope is at any point on the curve. So in this blank here, what we're going to do is we're going to use the gradient slope form, and we're going to fill in the yellow symbols with numbers or with representations of numbers to see what is the equation of the tangent line that's drawn to the right. So the y stays y, and the y subscript 1 would be the y-coordinate of the known point. So it would be y minus f of a equals, and now the slope is going to be the derivative function with x equals a plugged in, and then that's going to be multiplied times x minus, and x subscript 1 is going to be the a value here. Okay? At what angle is the normal line relative to the tangent line? Well, the normal line is this line here, or this line here, and you can see that it's perpendicular to the tangent line, so the angle is 90 degrees. Write the gradient of the normal to the curve at x equals a in terms of f dash a. Okay, so the gradient, and we're just talking about the slope, we're not talking about the equation of the normal line. The gradient of the normal line is going to be 90 degrees compared to the gradient of the tangent line. And the way we can take a slope and find the perpendicular slope to it is we do negative inverse of it. Okay, so the gradient of the normal line would be the negative inverse of the negative reciprocal of f dash of a. Okay. Number 1, find the equation of the tangent to this function here at x equals 2. So we are going to basically fill this in, okay, with real numbers. So first of all, our a value is 2, right? So what is f of a? F of a would be this function with 2 filled in. So it would be f of 2, which is equal to 2 minus 2 times 2 squared plus 3, right? Which would be 2 minus 4 plus 3, which is equal to 1. So our x value is 2, our y value is 1, And what is our derivative value or derivative function. Our derivative function would be 1 minus, and 2x squared, the derivative would be minus 4x, and plus 3, the derivative is 0. So our derivative function is 1 minus 4x. What if we substitute in x equals 2? That would give us 1 minus 4 times 2, which is equal to 1 minus 8, which is equal to negative 7. So our slope is equal to negative 7. And if I wanted to write the equation line, I would do y minus 1 equals negative 7, which is the slope, x minus 2. Where's the 2 from? It's from there. Okay? All right, let's do C. So there is our equation. Our y value, according to that equation, if we put 1 in there, it would be 1 cubed, which is 1, minus 5 times 1, which is minus 5. So 1 minus 5 is negative 4. Let's find the derivative equation of this. It would be y dash equals 3x squared minus 5. Let's substitute in x equals 1. If we substitute x equals 1, it would be 3 times 1 squared minus 5, which is equal to 3 minus 5, which is equal to negative 2. So, y minus negative 4 equals negative 2 times x minus 1. Okay, so that is our next equation of a line. And now finally, let's do E. So, this time it gives us the x value and the y value, so we don't need to find the y value anymore. We do need to find the derivative function to find out what the slope is of the tangent line. It would be, let's first of all just rewrite the function without these fractions. So we'll put 3x to the negative 1 minus x to the negative 2. Now let's take the derivative of that. It's going to be negative 3x to the negative 2 plus 2x to the negative 3. Now we're going to plug in x equals negative 1 to see what the derivative function is equal to at that particular point. It's going to be negative 3, negative 1 to the negative 2, plus 2 to the negative 1 to the negative 3. So that is equal to negative 3 to the negative 1 squared plus 2 to the negative 1 cubed, and they're both in the denominator. So this is positive 1, because negative 1 times itself is positive 1, and this would be negative 1. So what we get here is going to be negative 3 plus, minus 2 equals negative 5. Negative 3 minus 2, negative 5. Okay, so the answer is negative 5 for the slope. And then if we wanted to write the tangent line, we're going to use this equation again. So it's going to be y minus negative 4, so y plus 4 equals negative 5 times x minus negative 1, so x plus 1. Okay, so we use the x and the y coordinate right there provided. All right, so let's do number 2. Find the equation of the normal to y equals x squared at the point 3, 9. We're going to do almost the same thing. The only difference is instead of using the derivative function with 3 plugged in, we're going to use the derivative function with 3 plugged in, and then we're going to take the negative reciprocal of it. So they've already given us the x and the y coordinates. All we need to do now is find the derivative at x equals 3. So that would be y dash equals 2x. We're going to plug in x equals 3. So that means y dash is equal to 6 at that point. And now we're just going to fill in this function, right? So I'm just going to erase the things we're going to fill in. We're going to fill that in, we're going to fill that in, we're going to fill that in. So the x and the y values are 3, 9, so I'm going to put 3, 9 in here. And the slope would be 6 if it's the tangent line, but we want the normal line, so we're going to put negative 1/6 in. Okay? And the last one. So here's our xy value, that's fine. Then we're going to find the derivative of the function. So I'm going to put 5x to the negative 1/2 minus x to the 1/2. And I'm going to find the derivative of this. It's going to be y dash equals negative 1/2 x to the negative 3/2. Oh, what did I do with the 5? The 5 stays here. Negative 5/2 x to the negative 3/2 minus 1/2 x to the negative 1/2. And I want to see what is the value of the derivative at x equals 1. So I'm going to put 1 in here. So it's negative 5/2 times 1, blah, blah, blah. It doesn't really matter what the exponent is. 1 to the anything is 1. Minus 1/2, 1 to the blah, blah, blah. So we have negative 5/2 minus 1/2 is negative 6/2, which is equal to negative 3. So the derivative, so it would be the gradient of the tangent line would be negative 3. The gradient of the normal line is going to be negative 1 over negative 3, which is equal to positive 1/3. Now I'm going to write the equation. I'm going to put y minus 4 equals 1/3 times x minus 1. Okay, so that's the equation for that one. That's the equation for that one. Let's move on to number 3. Find the equations of the horizontal tangents to this function here. So we have a function here, and it's like a polynomial or whatever, and it has some horizontal tangent line, which means like this tangent line, this tangent line, this tangent line, all the tangent lines that happen to be exactly horizontal. How do we find that? Well, we're going to find the derivative of this red function first, and after we do that, we're going to set that derivative equal to 0, and then we're going to solve for it, okay? So let's find the derivative first. The derivative is going to be 3 times 2 times x squared plus 6x minus 12, right? I just used the power rule on those. So I'm going to simplify a little bit. 3 times 2 is 6x squared plus 6x minus 12. Let me factor that because I think that we can do that pretty easy. So x squared plus x minus 2, and that could be factored as x plus 2, x minus 1, which if we set that equal to, let's see, find the equation of the horizontal tangents to horizontal tangents. So we're looking for gradients equal to 0, so we're going to set that equal to 0, and we can see the only way that's going to happen is if x equals negative 2 or x equals 1. So now we could use slope gradient point form or point gradient form, but if we do that, we have to have the slope, and the slope in this case would be 0 because we're looking at horizontal tangent lines, okay? So remember, a horizontal line has the equation y equals something, right? So once we figure out the y values that correspond to these two x values, that's our horizontal line equation, okay? So because like if we have two specific solution points, we know that all we need to do is draw horizontal lines through those points because those are the tangent lines at those points. Okay, so what we're going to do is we're going to find the y values that correspond to x equals negative 2 and x equals 1. We're going to put negative 2 into the original equation to find that. So that would be 2 times negative 2 cubed, which would be 2 times negative 8, plus 3 times negative 2 squared, which would be 3 times 4, which is 12, minus 12 times negative 2, which would be positive 24, plus 1. So that is negative 16 plus 37, which is equal to 21. So this is going to be 21. And then if we put 1 in this function, we'll get 2 plus 3, which is 5, minus 12, which is negative 7, plus 1, which is negative 6. right? So those are our 2 points, and the horizontal tangent lines that are going through those 2 points would be y equals 21. That would correspond to this point here, and y equals -6. That corresponds to this point here. Okay? All right. Next one. Find k if the tangent to this function here at the point where x equals 2 has gradient of 4. Okay, so I guess that we want to find out this value here. And they gave us all sorts of other information in order to do that. They do tell us that x equals 2, this function has a gradient of 4. So let's find the derivative function, because that's the way we find the gradient. So the derivative function is going to be 6x squared plus 2kx, and minus 3 derivative is 0. And we're going to say that this is equal to 4 when x equals 2. Okay, so when that's 2 and when that's 2. So let's plug those in, and we'll get 6 times 4 plus 2k times 2, which would be 4k, equals 4. So that's equal to 24 plus 4k equals 4. So 4k is equal to -20, so k is equal to -5. Okay, so we figured it out. That's it for that one. 4a. Consider the curve y equals x squared plus ax plus b, where a and b are constants. The tangent to this curve at the point where x equals 1 is 2x plus y equals 6. Find the values of a and b. Okay, so we have this curve with some unknown coefficients. The tangent of the curve at x equals 1 is this line here. Now this line is given in a kind of a weird format. Let's see if that's going to affect us. Okay. Well, first of all, the tangent line could help us give us the y-coordinate, right? If we could figure out the y-coordinate of the point, like we have this function, this curve here, right? And oh, actually, it's a parabola, so we have this function, and then we have a certain tangent line, and then we can figure out this point here because we know it's x equals 1. Now, if we plugged x equals 1 into this, we'll get nothing because we don't know a and b. But we could plug in x equals 1 here, and that should give us the y-coordinate. So 2 times 1 plus y equals 6. Y equals 6 minus 2, which is 4. So y is 4. So we know that this point here is actually 1, 4. All right. If we know that, we could find either a or b, I think. So let's rewrite the curves equation with the a and the b in it. And now we're going to put in x equals 1, y equals 4. So it's going to be 4 equals 1 squared plus a times 1 plus b. Did that help? Not really, but we have a simpler equation with a and b in it. Let's do subtract 1 from both sides. We'll get 3 equals a plus b. Okay, that's a little bit of information. All right, what about the tangent to this curve? The tangent to the curve is 2x plus y equals 6. What is the gradient there? It's going to be y equals negative 2x plus 6. So now it's in gradient intercept form. The gradient is negative 2, right? So that means that the derivative of the function at x equals 1 is equal to negative 2, correct? So the derivative function of x squared plus ax plus b is going to be y dash equals 2x plus a. So I could set this equal to 2x plus a, and I know that a is 1, so it would be equal to 2 plus a is equal to negative 2. So my a value, if I subtract 2 from both sides, is minus 4. So my a value is negative 4. now that I know that the a value is negative 4, I could put negative 4 here, which means now I know that 3 is equal to negative 4 plus b. So b is equal to, adding 4 to both sides, 7. B equals 7.